So this beam has an overhang, and that 8 kilonewtons force right here at the tip, it's the whole reason most students get the wrong answer. And in this video, I will show you exactly how to handle it, and you'll finish with both reactions solved. Now here's what trips most people up. So when you take moments, the 8 kilonewtons at the overhang, which is 3 meters past that support A that we see there, this support right here. So that 8 kilonewtons, it's 3 meters past that point. And most students, they either forget to include it or they put the moment arm in wrong. And with either one, your RA and RB, they're both going to be incorrect. So we're going to set this up carefully, and I'll work through step by step so you will understand the full process. Now, the first step is to convert the UDL to a point load. So the UDL you see right here, that's 5 kilonewtons per meter over the full 8 meter span from point A, RA, to RB. So we can say then that the total load is going to be 5 times 8. And that's gonna give us 40 kilonewtons. So the UDL now, if I just erase that, always acts at the center of the span that we have the UDL acting. So let's say it's acting right there. So our 40 kilonewtons will now, let's say that's now going to replace that span, and it's replacing it as a point load. So that's our 40 kilonewtons. And since the UDL, it spans 8 meters across from RA to RB, this full length then from RB to the UDL point is just going to be 4 meters. So that's the 4 meter length for the point load now that's acting for the UDL. So we get rid of the UDL here now. So now step 2, we're going to take the moment about B right here at this point to the left. And why B? Because it will simply eliminate the reaction B. So we're left with only one unknown, which is going to be RA. So we're going to set up our system of equation to say that the sum of the moment about B is going to be equal to 0. And in this example, we're going to take our clockwise rotation as positive and counterclockwise as negative. So let's go through each load. So we have this 12 kilonewtons right there, which completely forget to include that dimension. So let's say it's acting 3 meters then from point B. So what we would have here then is just 12 and multiplied by 3, and it's going clockwise. That force is trying to rotate clockwise, so that's going to be positive. If we go across now to the next dimension, we have that 40 kilonewtons acting 4 meters from RB. Now, as I'm doing these, I'm just going to input the total as we go. So the 12 times 3, for instance, so that's 36. And the 40 times 4, so that's 160. And we'll add the units at the end. So now I'm just going to go across to that 8 kilonewtons, and that 8 kilonewtons, it's acting 11 meters away from our RB, which is our pivot point. And you can see it's also going to rotate in a clockwise direction. So I'm just going to add here plus 8 and multiply that by 11. So that gives us 88 kilonewton meters for that moment. So now RA is going to go counterclockwise. So RA force is acting like that, as you can see that arrow. So it's going to go counterclockwise. So I'm going to write this as negative because counterclockwise indicating that we have a negative turn. So we're going to have minus here RA, and multiply that by 8, and all of that equals 0. So we just have an equation here now to solve then. So if we were to do 36 plus 160 plus 88, that's going to give us 284. Take RA times 8 equals 0. So we get there 35.5 kilonewtons for RA. And we're now going to find what RB is. So for RB, we're just simply going to say the sum of our vertical forces should be equal to 0. And we're going to take forces going upward to be positive. So if you want, you can just simply add up all the forces going down and add up all the forces going upwards, and they should be equal. So with that, if you were to do the 12 kilonewtons plus your 40 and plus 8, then this will give us 60 kilonewtons. And that's representing all the forces going downwards. And what we have going upwards then is our RB and plus our RA. And that's what should equal to 60. And because we just found our RA, we can substitute our RA for the 35.5 that we just found. So we end up getting this then, RB plus 35.5 equals 60. So when we subtract 35.5 from our 60 that we have there, we get RB. So then RB is equal to 24.5. Now, once you've gotten your reactions, the next thing your tutor is going to ask you for is the shear force and bending moment diagrams. And for this beam, I'm going to post a video right here using the same beam, and it will go through that problem to create the shear force and bending moment diagram. So if you want more beam problems solved fast, then please subscribe to the channel and please check these videos out right here.